Let's begin. Today's September 28th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 9, 12, 16, 18, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at our 3-digit solution, and the Turing Machine will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at our first and last digit, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D, again, will take a look at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E will take a look at our 3 digits, triangle, square, and circle, add them together, and will let us know whether their sum total is an even quantity or an odd quantity. And finally, criteria card F again looks at our 3-digit solution, but this time it'll let us know a little bit about the structure, so to speak. Specifically, there are 3 scenarios. One where there are no repetitions, as in the example 1, 2, 5, or it could be a double number where there's a single duplication, as in the example 1, 1, 2, or finally it could be a triple number where it's a single digit repeated 3 times, as in the example 2, 2, 2. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I want to test is criteria card D. Okay, so the Turing Machine approves of the proposal. Notice that we are comparing even to odds. In my proposal, I do have 2 odds to a single even, so that means that there are less even than odds. Let's go ahead and type that up in our notes for section D. And that again is that there should be less even than odds. Next, I think I'll test criteria card E. Well, in this case, the Turing Machine does not approve of my proposal. We are adding the 3 digits, so let's go ahead and do that. So 3 plus 1 is 4, 4 plus 4 is 8. That is an even quantity, but the Turing Machine does not approve of that. So it is actually informing us that the sum of the 3 digits should be odd. So let's go ahead and type that up in our notes. So that is that triangle plus square plus circle should be an odd quantity. And what can we actually say about criteria card D and E? Well, again, criteria card D does guarantee us that we have a majority of odds, so we have at least 2 odds. So the sum of the first 2 odds are an even quantity, but if I want the total sum to be odd, that means I have to add yet another odd. So what this is telling us is that we have 3 odd digits. So the solution has 3 odds. Okay. All right. Moving on. Let's actually test criteria card F. Okay, so the Turing Machine does not approve of my proposal. Notice that I do have all distinct digits, so that is a no repetition. So, but the Turing Machine does not approve of that. So that means we can eliminate no repetitions, and we're left with either it being a double number or a triple number. So let's go ahead and type that up in our notes, and we'll state it as that the solution is a double or triple number. Now, I'm not sure at this point if we can deduce one or the other. It's really hard to say, so I think we have to keep our options open, whether there's a double or a triple number. Well, that does it for this round. We did complete our 3 Turing tests. We're now going to the phase where we'll be discussing how to construct a good second round proposal. So what I neglected to do is, since we did establish that there need to be 3 odd digits in our solution, let me go ahead and now take the opportunity to cross out all of the evens in all of the 3 digits of triangle, square, and circle. And what we did not test in the first round was criteria card A, where we're comparing the triangle digit, the first digit, to the number 3. We also did not test the number of 3s in our solution, and we did not compare the first and last. So since we do have the possibility of there being a double or a triple, notice criteria card C is comparing triangle and circle. Perhaps that could be our double. And of course, criteria card A comparing the first digit to the number 3. We know that, again, those are all odd values, so we don't have to bother with any of the even digits. And so that leaves us with how many 3s there might be. So, if we do have a single 3 in our solution, that would mean that the other 2 digits must be paired up. So that could be a strategy we do use. Otherwise, if there are no 3s, I guess it could still be a triple number, or possibly, there being a single 1 and 2 5s, or vice versa. So those are the possibilities that we're looking at. And let's see. Yeah, it could be perhaps maybe again the first and last digits are equal, and maybe that will tell us what circle would be, forcing square to be the other digit. So yeah, let's see if we can construct a 3-digit code with no 3 and 2 of the other. So let's go ahead. Let's do 151. Let's see where that takes us. Okay, so the first thing I think I'll test is if there are any 3s. So let's go ahead and test criteria card B. Okay, so it is true, since the Turing Machine approves of the fact that my proposal has no 3s. That is true. There are no 3s in our solution. So let's go ahead and type that up in our notes. And we'll state it as that the solution has no 3-digit. Okay, so that means we can cross out all the 3s for triangle, square, and circle. Okay, so now let's see. If there are no threes, yeah, I guess technically, I don't know. Can we still? Is there a way to deduce that it can't be a triple number? I guess. I don't know if it's a triple number, then. Well, yeah, you would know if there are three evens or three odds, so that wouldn't matter. Same thing with the sum of the three digits. If you have a triple number, you don't know if it's going to be an even quantity or an odd quantity. I guess the only thing you could say is if you do have a triple number, you would know that triangle is equal to circle. And so that would mean that the criteria card C would be irrelevant. I think that's the closest thing we could say to disqualify the fact that there's a triple number. So I am going on, I won't cross it out just yet, but that's my conjecture that there will be a double number. Okay, so let's go ahead and let's see. If I test, I don't think I can deduce either A or C. Yeah, so let's go ahead. I want to confirm if in fact the first two digits are equal to each other. First and last digits, triangle and circle. So let's go ahead and test criteria card C. Okay, so yes, the first two, or I keep saying first two, the first and last digits are equal. So let's go ahead and type that up in our notes. And again, that's in section C. And so, yeah, it is true that triangle is equal to circle. And we can't actually cross anything out officially because we don't know what triangle is. But that's what we're going to find out in criteria card A. And so, yeah, it is true. I did choose a 1 for triangle, and 1 is less than 3. So, yeah, it is true that triangle is less than 3. So let's go ahead and type that up in our notes. And so triangle is less than 3. And since it is less than 3, well, at this point, that means it's a 1. And so that means I can cross out my 5 value for triangle. And since triangle and circle are equal, it is also true that circle is 1 since they are equal. And that would leave us, well, let's see. We do have those two's equal. There is no 3. Let's see. Because we've already tested everything. We should have. Oh, I guess technically, we did not test F. Do we really have to retest it to verify? Again, my conjecture is that if you have a triple number, you would know for sure that criteria card C would mean that triangle is equal to circle. You would know that for a fact, but that would make that card irrelevant. So yeah, I'm going to go again. Now I'm going to officially say, yeah, it can't be a triple number because that would make criteria card C irrelevant. So I'm going to officially cross out the triple number. Oops. Okay. So I'm stating that yes, it's a double number. Triangle and circle are equal. So therefore, square cannot be a 1. leaving 5 as a value for square. So yeah, so I'm going with 151. Okay. Well, let's go confirm. So 151. And let's see. Okay, yes, that is correct. Now, how do we do versus a Turing machine? Well, we did have 6 criteria cards and we did 6 Turing tests. So that's a good indication that we won just by maybe merely a tie. So let's go ahead and type it up. In the first round, we did DEF, with D being the only correct one. And we were able to get the exact solution by the second round. So let's go ahead and type that up. DEF in the first round. So D was correct. Both E and F were wrong. And the remaining 3 were all correct in the second round. All right. Wow. Okay, so we beat it by 2 questions. So definitely, yeah, I feel, got lucky in the second round. I guess it was a good sort of deduction that there might not have been any 3s, and that would perhaps lead us, since we did have a possible double or triple solution, that triangle and circle were equal. So that was also a lucky break. It just broke our way. So what do you think about this puzzle? How did you solve it? Give any thoughts to how you solved it. If you notice anything about the video, add those thoughts to the comments. If you like the video, give it a thumbs up so that more people can find this channel. And of course, hit subscribe to not miss out on any future videos. Well, until next time, have a great one.